Last video we looked at the fractional form of a recurring decimal. We're going to do it again with another example here. We want to know what 6.27 is as a fraction. Now note the 27 there, it repeats. Sometimes it's written as 6.27 with a line over the 27. Alright? Now in this case, what you really have is 6.27, 27, 27. The 27 keep repeating. Now, what this is really 6 plus, you have 2/10 plus 700 plus 2,000 plus 7/10,000 plus the next one would be 200,000 plus 7. This is 100,000. The other one would be 100. Oh, let me check again. 10, 100, 1,000, 10,000, 100,000. Nice. Then the next one is 100,000 times 10, which is 1,000,000. Let me put the commas there. All right. Plus, and it goes on and on. Now, this is what we have. But what we want to do here, since we're going to be finding the common ratio, we want to have the same number repeating itself. Here you had a 2, then a 7, then a 2, then a 7. Let's combine the 27 together. This 2/10 plus 700, what does that amount to? This is really 2/10 plus 7/100. Let's use fraction. Common denominators, this is 20/100. So 20/100 plus 700 gives you 27/100. Alright, so it's 6 plus 27/100 plus, what about this now? We want to make sure that we get the right figures here. We did this part already. This part now. This is 2,000th plus 7/10,000th. If we have common denominators, multiply this 1,000 by 10 to get 10,000, multiply the 20 by 10. So we have 27 up top, 27/10,000. So it's 27/10,000. Alright? Plus, so we did this part. What do we have for the next part? This would be 2/100,000 plus 7/1,000,000. If we want common denominators, we multiply the 100,000 by 10 to get 1,000,000. We multiply the 20 by 10 to get to the 2 by 10 to get 20. So this is 27/1,000,000. So this is 27,000,000th plus, and it goes on and on. Alright? It goes on. Now, here, let me just erase this part. This is part of what we did in the previous video. Alright? I didn't erase all of the board. Let me just erase it. So now, here, we have the various terms of the geometric progression. Now at this point you might be tempted to say the first term A is 6. But the thing is now, what you really want is that the terms must be, let's say, divided. You must be able to divide one term by the previous term to get the common ratio. Alright? Let's assume that this is 6. Although it's going to be wrong, but I'm going to show you why it's not really 6. Let me put a mark there. Then we want the common ratio. What is the common ratio? If we divide 27 over a million by 27 over 10,000, this is 10,000, this is 1 million. What we will get is 27 divided by 1 million times 10,000 over 27. Cancel. We have 4 zeros. That's 10,000 into itself 1. Cross off 4 zeros here. And this becomes 100. So we have 1/100th. Okay, good. So this is suggesting that we have 1 over 100. If we want to make sure that this is really the common ratio, just to make sure there is no error, a while ago we divided this by this. Let's now divide this by this and see what we get. 27 over 10,000 divided by 27 over 100. This becomes 27 over 10,000 times 100 over 27. Cancel the 27. 100 into 100 goes one time. 100 into 10,000 goes 100 times. So this is 1 over 100. Good. We verified it. Now suppose we check further. And let us now divide this by this. 27 over 100 divided by 6. What does that give us? Will that give us 1 over 100? Let's see. This is 27 over 100 multiplied by 1 over 6. No, it doesn't work out. So what we have to do is change this and say the first term is really 27 over 100. As for the 6, we will put it aside. And later on we can put it back. Alright? Now, here we have these terms, 2700 plus 27 10,000 plus 27 million, and so on and so forth. It goes. Alright? The question now is, what is the sum? Remember, the sum to infinity is a over 1 minus r. So the sum to infinity of this is equal to 27 over 100, which is a divided by 1 minus 100. So let's work this out. It is 27 over 100 divided by 1 minus 100th is what? 1, let's do some fractions now. 1 minus 1 over 100 is the same as 1 over 1 minus 1 over 100. This means this 1 over 1 means the same as 100 over 100 minus 100. Now, 100 minus 100 give you 100 of anything minus 1 of it give you 99/100th. So you were dividing by 99 over 100. Alright? So 27 over 100 multiplied by 100 over 99 is what we get. Cancel down. We can say here that 3 into 27 goes 9, 3 into 99 goes 33. We can cancel further. This is 9 over 33. What do we get now? 3 into 9, 3. 3 into 33, 11. We have 3 over 11. So, here, what we have is 6. We'll write back the 6 plus, and then realize that all of this part, the point 272727 really is 3 over 11, which is 3, which is 6 and 3. Why am I writing 10 here? It's 11 that I should write. 3 over 11. This is 6 and 3 11th, which is what now? 11, 6, 66, 7, 8, 9. This is 69 11th. So, therefore, 69/11 is what we have. So we are saying here that 6.27 repeated is equal to 69/11. We can check on it with our calculator. Let's put 69 over 11 and see if we get the 6.27, so 2727. Let me put it in basic mode. Alright, 69 over 11 equal 6.27272727. It ends with 3 because it round it off, and then if you're going to stop at 2 when you round off and the number after it is 5 or more, you add 1. That's why you see a 3 at the end. So what we have here is 6.27, where the 27 repeats, is equal to 69/11.